Hello, and welcome to this introduction to SPC5Studio, an integrated development environment for ST's SPC5 family of 32-bit automotive microcontrollers. SPC5Studio is a visually based, application-oriented integrated development environment. It's not just a software editor and not just an operating system configurator, but an end-to-end application development environment. SPC5Studio is built on Eclipse IDE, which is an industry-standard open platform. Since Eclipse is open source, anyone can play with it by adding features, new software modules, including software for our specific applications. Because of this flexible customizability, ST and our partners were able to create an application development environment tailor-made for our SPC5 MCU family and automotive applications they are designed for. SPC5Studio combines a project editor, a sophisticated code generator, a compiler, a PLS starter kit debugger, and several software elements including code examples, low-level drivers, and libraries. With SPC5Studio, automotive application developers can build up an application within minutes. SPC5Studio is part of a larger development environment for the SPC5 family and includes support for the entire SPC5 family of 32-bit MCUs, board support packages for all SPC5 lines that are compatible with SPC5Studio, PLC debuggers that are purpose-built for integration with SPC5Studio, and discovery kits for SPC56 and SPC57 MCUs. SPC5Studio is based on a visual configuration approach. Configuring all of the attributes of your application means that everything is ready for setup just by working with a visual interface and filling in a form without any code editing. Another time-saving feature is the visual pinout configuration wizard. Once you have specified which microcontroller you need, you can visually configure the GPIO pin by pin, and SPC5Studio will automatically generate the code for the initialization of the device. Developing an application has never been easier. Using the SPC5Studio's new user interface, we are going to show you how to import an application example using the application wizard, configure the main components, and generate and build code. Launch the tool and close the welcome page to access the application wizard. Then select the platform and MCU you want to program, for example, P-Line family and SPC56P discovery board. Select the type of application, for example, serial using the RLA driver, and click Finish. The README file provides a description of what the application does. The main file covers the peripheral's basic operation. The application example settings can be configured through the configuration.xml file. The MCU can be changed by accessing the platform component. All configuration settings at this level can be changed through the outline window, such as boot modes. For each setting, a contextual description is available through the Property Description window. Through the Build Settings outline menu, you can access all the compiler settings and change the optimization level or the selected compiler. SPC5Studio 4.0 comes with a free GCC compiler. Using the Linker Settings menu, you can change the settings for the linker. By accessing the low-level driver component RLA, you can enable or disable additional drivers. Any change can always be rolled back to the default configuration setting. You can change all driver settings, for example, the serial driver's default bit rate or the LinFlex configuration. By accessing the board's initialization component RLA, you can change the external oscillator settings, configure pins, change the mode, port, latch state, and so on. SPC5Studio is equipped with a visual pin map wizard that makes it easy to configure pins as specified in the reference manual. Pins are configured by setting the pin behavior with a simple right-click on the mouse. This can be done, for example, to configure the LinFlex settings. Don't forget to save before exiting. Additional pin settings are available through the Alternative Inputs menu in the Outline window. User interrupts can be added through the IRQ component RLA by simply clicking Add, setting the identifier and priority, and then saving it. SPC5Studio is equipped with a visual clock tree, which is used to set a clock chain from the external or internal oscillators up to the single clock peripheral. PLL settings are easily changed by right-clicking on the mouse. As you can see, the system clock is changed, and if the ODF value is set back to its original value, the system clock goes back to the 64 MHz configuration. Additional clock settings are available through the clock initialization settings in the Outline window. Once all the settings are configured, save all changes, and you are now ready to generate the source code using the Activity Wizard. You can find the generated code in the Components window in the Project Explorer window. Each subfolder contains the generated files grouped by content. Driver source code is inside the low-level drivers component folder together with the configuration macro. All functions are clearly commented in the source code to allow for easy understanding, and in case of need, you can modify them to fit your application. Once the modifications are saved, you can build your application using the Activity Wizard. The progress is displayed in the console window. SPC5Studio is linked to the PLS Debugging UDE Starter Kit that can be launched after the build using the Activity Wizard by clicking Debug. Your application is completed and ready for debugging. We hope you found this video useful and you are now ready to create your own program. For more information, visit www.spc5studio.com.